Hi class, here we go again, the second lesson for inequalities. Today I want us to discuss compound inequalities, compound linear inequalities. Why compound, why linear? In fact, lesson one I forgot to have written or indicated linear inequalities. Why linear? We are dealing with one variable, not only that, the highest power of the variable is one. So the fact that the highest power of the variable is 1, that makes it linear, just like equations. So here again, though they are compounded, but what the highest power of the variable is 1. That makes them linear again. So why compound? Because of we have two inequality symbols. All right. So the first one says 2 less than 3x minus 1 less than 11. See, we have two. We have two ways to do this one, but the other way, it will take us more steps, and more steps will attract more time. So what we do is, but basically we want the variable to stand between the two symbols. We have this symbol, we have this. So end of the process, this x is supposed to be at the midpoint of or between two symbols. So since the final answer is supposed to have the variable between the two symbols, so let us be doing that one from the beginning, from the very starting point. So what we do is, we want only x to start here. So in other words, we don't want minus 1 here. But what do we do so that we can remove minus 1 here? The only way we can remove minus 1 here from 3x minus 1 is when you say 3x minus 1 plus 1. You know that minus 1 plus 1 will be 0. So minus 1 will be eliminated. See what I'm trying to say? Now look at this symbol. It is this. Look at this one. It is this. Okay. But we don't want minus 1 here because the final answer is supposed to have only x between the symbols. So the only way to eliminate this is when you say 3x minus 1 plus 1. Why is it plus 1? Because minus 1 plus 1 will be 0. So this one will go away, leaving only the x term. And that is what we want. But don't forget that whatsoever we added here, we multiplied here, we subtract here, must also be done on any side. So the fact that here we say plus 1, here you're supposed to say 11 plus 1. Here you're supposed to say 2 plus 1. I hope it is clear. So 2 plus 1 is 3. We have this. So minus 1 plus 1 is now 0. You can see, of course, you know, 1 minus 1 is 0. So what remains there is 3x. This is less, and this is 12. We are not finding 3x, though we've succeeded in eliminating 1, but we are not finding 3x. We are finding only x. So divide by this 3. This 3. Okay. We are not dividing by 3 because here is 3. We are dividing by 3 because we want only x alone, just x. So this goes with this. This into this is 4. It goes with this. What remains here is 1. Here is less. Here is x less than, and this is 4. And this is what we want. This is what we want. So x is greater than 1 but less than 4. I hope it is clear. Now let's go to the second one. So the second one says minus 1 less than or equal to 2x plus 3 less than or equal to 7. The same thing applies everywhere for linear inequalities, for compound linear inequalities as well. So we want only the x term between the symbols. So because we want only the x term between the symbols, look at the symbol here, less than or equal to. This one, less than or equal to also. But we want only the 2x, meaning we don't want this 3. But it comes with plus 3. So we only need to say plus 3 and say minus 3. If it comes with minus 3, when you say minus 3 plus 3, what you have here is what you just change the sign and write the same value. So 2x plus 3 This is what we are given. Then we say minus 3. Why? Because we know that plus 3 minus 3 will get eliminated. But remember, here we say minus 3. We must do the same thing here. 7 minus 3. This is minus 1 minus 3. I hope it is clear. Why this one? Why is it this one working? Now let me create a simple scenario. Now let us say you have 9 mangoes. Your friend has 4 mangoes. You have more mangoes than your friend. So we can say 9 is greater than 4. So the question is, if you have 9 mangoes, you have 9 mangoes, your friend has 4 mangoes. Now the question is, how many more mangoes do you have? How many more mangoes do you have? You have 5 more mangoes. Is that also? All right. Now, what if someone takes away 2 from you? Yes. You start saying, well, why my father or my mother has to take 2 from me? But you'll have no problem if the same number of mangoes is taken from your friend. 9 minus 2 is 7. 4 minus 2 is what? Is 2. How many more mangoes do you have? You still have 5 more mangoes. So the only way we cannot create a problem is that if we add something here or we subtract, as long as we do it here, no problem at all. Okay. So this gives minus 4 less than or equal to minus 3 plus 3 minus 3 goes, we have 2x less than or equal to 7 minus 3 is 4. We are not finding 2x. We want only x. So what is in front of x is 2. We divide by 2. So this is 2. This is 2. So here is minus 2 less than or equal to x less than or equal to 2. So once we have just x, then it is over. We go to the third one. So the third one says 4 less than or equal to 5 minus x less than or equal to 9. The sign here is less than or equal to, here is less than or equal to. All right. So what do we have here? We have 5 minus x. But we need only the x term. Can we say plus x? No, if you say plus x, minus x plus x will eliminate the x from being between the symbols. Once you add here plus x, you add here plus x, you add here plus x. So you've eliminated x from being between the symbols. And x has to be between. So it means we are not using x here. What we are using 5. What sign is this? Plus. So we say minus 5. Why? Because 5 minus 5, they will go away, leaving only our desired x. So because we say minus 5, so here again we say 9 minus 5. Here again 4 minus 5. So 4 minus 5 is 1 minus 1. So this 5 minus 5, they will go away, leaving minus x. So less than or equal to 9 minus 5 is 4. Are we finding minus x? No, we are finding x. So what is in front of x? Minus 1. The idea of dividing both sides by minus, we don't have it in mathematics, not accepted. Unacceptable. Please do not say, we don't have anything like minus in mathematics, just minus. We say minus 1. Yes, they can tell you minus times minus is plus. That one is all right. But we don't have a quantity said minus. So you have to say minus 1. Minus 1. So this goes with this. This goes with this. So what is left here is 1. Yes. Do not forget what we did in the first lesson, that when you divide or multiply both sides by a negative value, the symbols have to change direction. This was pointing this way, it now goes this way. So here it means x. This was pointing this way, it now goes to the other's opposite. So plus divided by minus is minus 4. I hope it is clear. Okay, so let's see what we have again. The last one. Don't forget this one. The fourth one says 3 less than x plus 1 over 2 less than or equal to 5. Before we think of eliminating this one is a fraction. So let us try to eliminate the denominator, which is 2. How do we eliminate the denominator, which is 2? We multiply every term by 2. So this 3 is multiplied by 2 less than x plus 1 over 2 is multiplied by 2 less than or equal to 5 multiplied by 2. Whatsoever you do on one side must be done on the other sides. So this takes away this. So this 3 times 2 is 6. This is x plus 1 less than or equal to 5 times 2 is 10. So it has now become a normal inequality. So we don't want x. We have this symbol, we have this symbol. So since we don't want this one, we say x plus 1 minus 1. So 1 minus 1 will go away, leaving our x. So since here we say minus 1, here again we have to say 10 minus 1. Here again 6 minus 1. So 1 minus 1 go away. 6 minus 1 is 5. Here remains only x less than or equal to 10 minus 1 is 9. Can we change this symbol, the directions? No, because we don't divide by a negative value. So this is single x. This is what we have. So thank you for watching. Don't forget to follow, like, share, and comment. See my next video.